So I'm solving Codeforces around Halo 2023 and I'm on B. So I submitted an incorrect submission. So I thought for odd number of elements we cannot make an array where we have the sum of any two adjacent elements equal to the sum of the whole array. I guess that part was wrong. So let's take for instance 5. So I'm assuming that we are gonna take two variables x and y alternating. This is the theory that is I think is correct. So by this formulation the equation that comes out is this, and x plus y is equals to z. Because the reason why I'm taking like these alternate characters is because we need adjacent characters to also equal to the same. So if there is an x plus y here and we have the third element with the second element, if this is y then this has to be x because x plus y was there before. So that was the theory, and so this leads us to these two equations. If I subtract both of these equations, or I just multiplied this with 2, so I get a z in my equation. So z would be minus 2z or minus z. Minus z would be equal to x. So that is weird. Now let's eliminate z. So eliminating z, we will get 2x plus y is equals to 0, which is equals to minus y, which is equals to x equals to minus y by 2. So let's take x to be 4. So 4 and minus y by 2 would be equal to minus 2 and then 4 and then minus 2 and then 4. So the total sum turns out to be 12 minus 4, that is equal to 8, but the sum doesn't actually equal to 8. What kind of wizardry is this? Okay, oh my bad. Let's keep y as 4. So this should be minus 2, this should be 4, this should be minus 2, this should be 4, and this should be minus 2. So the total sum comes out to be 8 minus 6, that is 2, and the sum of individual characters sum of adjacent is also 2. Okay, so I guess we can do for 7 now. This kind of works. It's crazy like how it works. Let's assume index to be equal to 2 times something. Let's do it for 7 and let's observe the pattern. Okay, so for 7 the equation is going to be one of the integers is going to be 4x, 4 multiplied by 4, and other is going to multiply it by y 3 times, and this is going to be equal to x plus y. So this turns out to be 3x plus 2y equals to 0. So this turns out to be x is equals to minus 2y by 3. Weird. Let's do it for 9 as well. So So I'm guessing 9 would be just be one smaller than this, so this would be 9 would be 4x plus 3y equals to 0, and minus 3 divided by 4, so minus 3y by 4. So by choosing a sufficiently high y that is divisible by 4, we can execute. So the constraints are n goes up till 1000. So for 1000 we can 1000 is an even number, so the closest odd number is 999. So this would be divided into two parts, and that would be 500 and 499, I believe. So 500x plus 499y should be equal to x plus y, which turns out to be 499x plus 498y should be equal to that thing, and x turns out to be minus 498y divided by 499. So a number that is divisible by 499, that can be 499 itself. So we're gonna take, so if the number n is odd, then we're gonna take what? We're gonna take a half of that. So I'm gonna declare the number int half is equals to n by 2, and this is integer multiplication, and let's take a second half variable half plus 1, let's say half plus 1, right? And so the y would be equal to half. So int x would be equal to half minus 1, in fact half into minus 1, right? No, wait, half minus 1 into minus 1, I guess. Why? Because I observed the pattern that in this pattern, if I keep y to be equal to 3, I get minus 2, and in this pattern as well. So if I take that, and then I can just use the above loop to print out the answer. X. So if I mod 2 is equals 0, I can do this. Mod is a heavy operation, but we don't have to optimize for this for now, at least. I could create a test case for this. What could be the test case? I would go for 5 and 500. So I'm gonna do that. Wait, how is this printing out two answers? Okay. So only for 3 it is not possible? That's weird. So even for 3 this should be possible, right? Okay. So for 3 they have printed 0 and 0, which is not possible. Let me add a test case where I have a 5 as input. So I get a yes and a no. Forgot to increase the number of test cases. Let's increase to 5, and let's see for 500 as well. for 1000 as well, and for 7. Okay, this is completely wrong. Oh, this is right, in fact. सोनिए पराठा नी पराठा चाहिए फिर मिलूंगा जो तेरे नैना सोनिए. Okay, so for 5 this is printing out this, which is weird. So -1 plus 2 is 1, -1 plus 2 is 1 again, 2 minus 1 is 1 again. Okay, so it beat me to the algorithm. For my 5 the answer was something different, but I guess this works. I could create a test case where I actually check the generated array for the condition, but I'm not gonna do that. Just gonna submit this. Fuck. Okay. I guess creating a test case wasn't that bad. Wait, this is printing bullshit. How is this printing 2 fucking arrays? Four, 2, 3, 5, 7. So for 2 it's printing this. For 3 it's printing no. For 5 it's printing this array. For 7 it's printing this array. But instead just should print yes, and then that's a wasted pretest too. Oh my god, I just wasted my I just got a -10 or 10 minutes penalty for absolutely nothing. For just a displaying issue. I fucking hate this. They should create better test cases, right? Whew. So I've already done A. That was pretty straightforward. So you basically need an RL in this one. So if there is an R to the left of any L, the answer is 0. And if you have an LR kind of thing, then the answer is 1. And yeah, you can just print the answer is not 1, you can just print the index. So you can also get 0 0 here because you already have an LR. This is just a valid solution even if you flip these bits. So this was something that was confusing me. So the answer can be 0 0 here. Read this. Okay, that's why I got a bit late in submitting this question. Okay, let's move on to C. Let's create an input file for C as well. So in C it says Baltic, a famous chess player who is also a mathematician, has an array and he can perform the following operation several times. Choose same index I, multiply AI with -1. Why does it look like I've read this before? As always, let's take the input n comma n. Oh, we have n first. Man, this would lead to so many silly mistakes one day. So AI is up till 10 to the power 9, and if we want to add any of that shit, we need to take a vector of long, let's say. Let's debug this. G++ c dot cpp, output goes in C, and after that compile C and give it c dot input. I guess that is rendering the correct array. So we have taken the input correctly. So the question says that choose some index I and we can replace the number with the negative of that number. And he wants the prefix array of size m to be the smallest, to be of the smallest sum. To be the smallest basically. So out of all the prefix sums, this should be the smallest. So for it to be smallest, what do you think? A prefix with m-1 would always be greater than m if a of m is greater than 0. So of course a of m should be lesser than 0 or equal to 0, because they can be same, right? As it says greater than equal to. So it can be shown that a valid sequence of operations always exists. I don't know how am I gonna sum that. So they want a prefix of 3 to be the lowest. Okay, we can just print out negative numbers. What do we have to output? Minimum, we have to minimize the number of operations. Okay, -3 up till here, and we can just replace this -4 with a +4. So that's one operation. In this one we can just flip this 3, right? And in this one it's already done. In this 5 we can use all negative numbers. So this is kind of happening at this point. I'm gonna create a long I could create a prefix array. I can create a prefix array. So we have minus 1, minus 3, minus 6 plus 10. So we want to minimize the prefix at element m. This is not 10. What we want to minimize? We want to minimize m minus 1, I guess. Let's just take long max. So the answer is pretty straightforward. If this is the answer, we just print out 0. Now we have to do the work. Let's keep an index instead of this. Let's keep it 0. If the index is greater than m minus 1, actually that doesn't make any difference. So let's say m is somewhat here. This guy is m. So we want these summis to be greater, and let's say the greatest is at here. So we want all of these to be in the negative side, I guess, or even one can reduce the effect. I don't even know. So if we have a negative 2 here, the prefix of all of these numbers would just keep on decreasing, or could be greater than prefix at m minus 1, because even though this is negative, this could not be, there could be a number like 55 that would totally destroy it. So I'm gonna do this question. So in the fifth example, a3, a2, a5. That's a weird set of combinations that this guy took. I mean, by decreasing all other, I can make this to be the largest, but that would not be in the minimum number of operations. So I need to figure out something else. End up in so at least one is the answer. Why? Because we have to yeah, that's pretty much obvious. Is it possible that a of m is greater than 0? No, right? What I'm saying right here is that in the final array, where the prefix of m is the greatest, is it possible that a of m is still greater than 0? So I guess that is not possible. So the first operation that we can do is make a of m negative if it's not already. So like -2, -2, -3. So this is if this is negative, this should be smaller than the sum up till here, and if this is negative, so now it's definitely smaller than prefix of m minus 2. What about prefix of m minus 3? Is nothing but prefix of m minus 2 plus a of m minus 2. So this can only be smaller than this if this is negative. So if all of these are positive, then we don't need to change that. But if all of these are negative, then it depends on a lot of things, like so for this the prefix sum is -2, -4, minus but it could be like -20, -2 and -3. No, but it actually adds up. So the more smaller this number is, the more smaller this becomes. So the problem is not with all negatives, the problem is with a positive now. So if it's -20 and this is +2 and this is -1, let's say, so we have prefix sum as -20, -18 and then minus minus 19. So this is not the smallest here because this is the smallest. So to make this to be the smallest, I can either convert this or I can convert this. I guess I can't do any more questions at this. Good contest, decent contest. 9,000. Oh shit. And only 1,700. Damn. I'm gonna lose rating on this one as well. Shit. No more Sharma ji doing contest. Oh no. Where is Sharma ji? So Sharma ji became masters and just left. Nah. This contest is probably not rated for them, I guess. This guy. I really want to solve one more question. पराठा चाहिए. So in the fifth example, we converted 2, 3 and 5. 2, 3 and then 5. So after the m minus 1th element, so I'm gonna have a variable named long adder I'm gonna increase the addition by a of I, and as long as the addition is negative or 0, we can be sure that all prefixes after it are smaller than it. So if add is greater than 0, then we can say that we need to make a of I, or we can say the answer and then we can do add minus equals to 2 into that number. This is not allowed. This would take care of the right half, I guess. Or this might actually be greedy approach and this might be wrong. Here is why it could be wrong. Nah, it's right, bro. It's right. Because can you think of a test case where multiplying it with a -1 earlier would have been fruitful, like a big number like 812,000? If we change this to negative, all of the others like 2 plus 3 plus 4 would become negative, but then this would already be negative, right? Because of this algorithm, because addition can never be positive. Do you get my point? So this will always become negative no matter what. So we have 2 3 4 here. These will become negative, these will become negative, these will become negative, everything fucking will become fucking negative. So this will work. And now the only case that is left is of the numbers from 0 to m minus 2 inclusive. What do I do for them? Because if I change the number to a negative of a of I, this not only changes the prefix till that point, this also changes my total prefix, or the prefix at m minus 1. सोने पराठा नी पराठा चाहिए This is the perfect example that we need to take care of. I think we can just take the largest number from the left side, and convert it to positive. Or convert all of the numbers to negative. So I'm going in the direction, if all negative, then we are cool. But if all positive, what about all positives? All positives is bad, but it can be good in some scenarios where 2, 3, and we have a minus. So this is 2, this is 5, this is 2 again. This is fine. But this is not fine. Like 2, 3, minus 2. Oh wait, I just fucked up. This one is wrong as well. We need addition to be greater than 0. Fuck my life. I thought we wanted to make the prefix max, so I did this shit. But we want to make it the minimum. So if addition is less than 0, so this is going in negative. Sonia Paradani Parada Chayre. As long as addition is positive or 0, we can be sure that prefix of m minus 1 is the freaking smallest. So for 0 to n minus 2, what I'll do is I'll pick one number randomly. I'll change it. I'll see if it fixes everything. every fucking thing. And if it does, that's a bad approach again. I don't know, man. I don't know. I want to pick the largest element, flip its polarity, if it's positive, of course. And keep on doing that for every okay. But what if the start is we can't touch start, right? If it's positive. And even if it's negative. If it's negative, you won't anyway. Touch it. No, we can't touch it, right? If it's negative. But we can use it to increase before some, but it will also increase prefix of m minus 1, right? By the same amount. By the same amount, right? So then this is of no use, I guess. सोनिए पराठा नहीं बनाना चाहिए. since changing a negative number to a positive will increase the prefix sums of earlier matrices, but it will also increase the prefix of m minus 1 by the same amount. So it's not actually helpful in my opinion. So leave the negatives, I guess. Leave the negatives. Think of changing the positives, I guess. Yeah, I guess. So for positives, which positive to change? So let's consider a case where even having a positive in your prefix array would still lead to your m prefix of m minus 1 to be negative or smallest. In that case is like somewhat like this. So we have a plus 1 and minus 2. So we have minus 20, we have minus 19, and we have minus 21. So it's still the smallest even though we have a plus here. You be like me yellow. So what I can do is for Like me yellow. But the problem is we can't change we have to change a positive number occurring after it. But which positive number? There could be a +2 that have no effect, no real effect. So we have -20, then we have -18, then we have -182, and then -3 would be. So certainly changing this would not be of much help than this. This would changing just -200 will change everything. Right. So this will reduce our prefix of m-1 by But how will we check? Is it enough? We can keep a count of all the minimums or all the lows, but the lows occurring after the element would also change, and they would change by, they would actually go smaller, right? So every low after that point will also decrease by that same number. So if there is a low that is after that point or after the positive 200, so if there is a low here like -20, let's say, and then there has to be a plus something, let's say +21 or +25. And this I'm talking about the prefix. Let's say -10 comes out to be my prefix. So let's say there is a -5. So this one will still remain lower than this. So how will I fucking change this? How will I increase this? How will I increase this prefix? If I change this to -200, this is gonna decrease by -400. All of these are gonna be decreasing by -400. But I want to, so I have to add something after this, right? So I have to change a positive number after this, so that I can actually decrease this prefix from this one. Flip it or not, that is the question. Flip it or not, that is the question. To flip it or not. Because it could be that changing this will suffice. So I actually have to go the other way. So 1 minus that. किया तो है यहाँ पे डिफाइन.